Hello students, welcome to Physics Bouquet. In this video, we will discuss solution of Laplace equation using Cartesian coordinate system. Solution of Laplace equation using Cartesian coordinates. पहले Laplace equation. Let me write Laplace equation. Any equation in this form. Del square u by del x square, del square u by del y square, plus del square u by del z square is equal to 0. Or in short, it is written as del square u is equal to 0. You come across such equation in electrostatics while reading electric potential. So this is Laplace equation and u is a scalar here. We have to find out the solution of this equation using Cartesian coordinate system. So इसका solution निकालते हैं using the method of separation of variables. So again we can write u is the product of three functions x, y and z. This Laplace equation be given number 1. Here x is function of x only, y is function of small y only, and capital Z is the function of small z only. Let it be equation number 2. Now find second derivative of u with respect to x, with respect to y and with respect to z. We have del square u by del x square. Since we are taking derivative with respect to x only, so y and z remain constant. So yz we have d square x by dx. I am writing full derivative, and del square u by del y square is equal to, here with respect to y means xz remain constant, so d square y by dy square, and similarly del square u by del z square is equal to xy d square capital Z by d small z square. Now use these three in equation number 1. Using these three in equation number 1, we will obtain yz d square x by dx square plus xz d square y by dy square plus xy d square z by dz square is equal to 0. Let us divide this equation by x, y and z. We will obtain, dividing by x, y, z, we get 1 by x d square x by dx square plus 1 by y d square y by dy square plus 1 by z capital Z d square z by dz square is equal to 0. Let it be equation 3. Now this equation 3, it can be written as 1 by y d square y by dy square plus 1 by z d square z by dz square is equal to minus of 1 by x d square x by dx square. And let it be equal to a constant, let it be alpha square. Since these are second derivatives, I have taken square of this. See, this is a constant, arbitrary constant. Now equation 4, from equation 4 I can write minus 1 by x d square x by d small x square is equal to alpha square, or d square x by dx square plus alpha square x is equal to 0. By taking the auxiliary equation, what will be the auxiliary equation? Auxiliary equation is m square plus alpha square is equal to 0. So m plus I alpha into m minus I alpha is equal to 0. This implies m is equal to plus or minus I alpha. So its solution will be, solution is x is equal to, I can write a exponential I alpha x plus b exponential minus I alpha x. Let it be equation number 5. Again from equation 4 we can write this 1 by y d square y by dy square plus 1 by z d square z by dz square is equal to alpha square. So let us write 1 by y d square y by dy square plus 1 by z d square z by dz square is equal to alpha square, or I can write 1 by z d square z by dz square is equal to alpha square is equal to 1 by minus 1 by y d square y by dy square. देखो students, here a student can do like this also. This is equal to alpha square minus this. It can be done. Or this minus alpha square is equal to minus of this. So doing in these ways there will be two different types of solutions, but nothing to worry, both are correct. So adapt whichever you like. So let us proceed. Now this side only z, this side only y. So let us have another constant, suppose beta square. That means let it be equation number 6. From equation number 6 I have minus 1 by y d square y by dy square is equal to beta square, or I can have d square y by dy square plus beta square y is equal to 0. As a result, after taking auxiliary equation, I can get y is equal to, let us have arbitrary constant c exponential I beta y plus d exponential minus I beta y. Let it be equation number 7. So in equation 6, in equation 5 we obtain capital X, here we obtain expression for capital Y. Now for capital Z, let me again come back to equation number 6. From equation 6 I can write 1 by capital Z d square capital Z by d small z square minus alpha square is equal to beta square. Or I can write 1 by z d square capital Z dz square minus alpha square plus beta square is equal to 0. Or d square capital Z by d small z square minus alpha square plus beta square into z is equal to 0. Let us write alpha is constant, beta is constant. Let me write another one t square, or I can write another solution directly, d square z by dz square minus gamma square z is equal to 0, where gamma square is equal to alpha square plus beta square. Or instead, or its auxiliary equation will be m square minus gamma square is equal to 0. That means m is equal to plus or minus gamma. Hence, here I had written x, a exponential I alpha x plus b exponential minus I alpha x. Now its solution will be z is equal to, let me write, e exponential gamma z plus f exponential minus gamma z. Right? Now x, y and z are obtained. Let it be equation number 8. Now use equation 5, 7 and 8 in equation 2. What is equation 2? Equation 2 is u is equal to x, y product of x, y, z. So we obtain the ultimate solution as u is equal to a exponential I alpha x plus b exponential minus I alpha x into c exponential I beta y plus d exponential minus I beta y into e exponential gamma z plus f exponential minus gamma z. So this is the final solution. Dear students, I want to say something. In some books, some authors, some teachers, here they express the solution in terms of cos and sine function. You see, exponential I alpha x, it can be written as cos alpha x plus I sin alpha x. This is cos alpha beta b into cos alpha x minus I sin alpha x. So, on the whole, it can be written as a cos alpha x plus b sin alpha x. In some books, it is written like this also. This in so sine cosine terms can be used to express the solution. So nothing to worry. You can express like this. This is the final solution. This much today, and we will meet in next video with a new topic. New topic matlab solution of Laplace equation using cylindrical coordinates. Have a good day.